Okay, let's move on to question number 1. What is recommended backup destination for Exadata database service in Oracle database at Google Cloud? Okay, let's look into the options. Option A, local storage on Exadata VM. Local storage lacks durability and scalability for enterprise backups. So option A not a correct choice. Moving on to option number B, autonomous recovery system. Autonomous recovery system is not natively integrated with Google Cloud infrastructure. So again the wrong choice. Moving on to option number C, Google Cloud Storage. Google Cloud Storage aligns with a cloud native backup strategy within the Google Cloud environment. So option C might be a potential answer. Let's keep it. Moving on to option number D, OCI Object Storage. OCI Object Storage is not preferred when operating within Google Cloud infrastructure. So option D not a correct choice again. So option C will be the correct one. Okay, let's look into question number 2. What is recommended CIDR size for Exadata database service subnet in Oracle database at the Google Cloud? Okay, let's look into the option. /32. /32 provides only one usable IP address, which is insufficient for deploying any Exadata VM cluster. So option A not a correct choice. Moving on to option number B, /29. /29 provides only 6 usable IP addresses, which is insufficient for deploying Exadata VM cluster and supporting related services. So option B no. Again wrong choice. Moving on to option number C, /24. /24 allocates 256 IP address, which is more usable than needed for Exadata deployment and may lead to insufficient IP utilization. So option C also incorrect. Moving on to option number D, /27. /27 provides usable IP addresses to support Exadata VM cluster while maintaining efficient subnet sizing. So option D will be the correct choice. Okay, let's look into question number 3. How does the copy to another region feature in Oracle Cloud Infrastructure aid in achieving smooth transition during block system migration? Which is this if required before provisioning Oracle Autonomous Database in Oracle Database at the Google Cloud? Okay, very interesting question. Okay, let's look into options. Option A, Google Cloud Virtual Private Cloud (VPC). Google Cloud VPC is required to define the network environment for autonomous database provisioning. So option A might be a correct choice. Moving on to option number B, Oracle Cloud Infrastructure VCN. OCI VCN is not used in Google Cloud hosted deployment. So option B not a correct choice. Moving on to option number C, Exadata VM cluster. Exadata VM cluster is not required for autonomous database, which is serverless. So option C again wrong choice. Moving on to option number D, Oracle Identity and Access Management. IAM is used for access control but not a prerequisite for provisioning and Google Cloud. So option D again the wrong choice. So option A will be the correct choice. Google Cloud Virtual Private Cloud. Okay, let's look into question number 4. What is the purpose of SAML metadata file in an OCI Federation setup in Azure Active Directory? Okay, let's look into options. Option A, it used an exchange metadata information between Azure AD and OCI. The SAML metadata file contains configuration detail that enables Azure AD and OCI to exchange identity federation information. So option A might be a potential answer. Let's keep it. Moving on to option number B. It is used to establish trust between Azure AD and OCI. Trust is establishing through certification and configuration, not the metadata file alone. So option B again the wrong choice. Moving on to option number C. It is used to store credentials for authentication. Credentials are never stored in metadata files. So again the wrong choice. Moving on to option number D. It is used for configuration attribute mapping between Azure AD and OCI. Attribute mapping is configured separately within Azure AD and OCI setting. So again the wrong choice. So option A will be the correct one. Okay, let's look into question number 5. What is the purpose of a federation trust in Oracle Cloud Infrastructure Identity Federation? So let's look into the options. Option A, to enable PCO to create a user account for federation users. User accounts are mapped, not created by PCO during federation. So wrong choice. Moving on to option number B, to encrypt the user access token during the authentication process. Authentication is handled by protocol, not federation trust. So again the wrong choice. Moving on to option number C, to store user credential locally within the server service provider. Federation avoids local credential storage by delegating authorization to IDP. So again the wrong choice. Moving on to option number D, to establish a relationship between the identity provider and the service provider for authentication. Federation Trust defines how OCI and IDP communicate for authentication. So option D will be the correct choice. Okay, let's look into question number 6. What is the purpose of an Oracle infrastructure identity domain? Okay, let's look into the options. Option A, create isolated network for resource within the tenancy for enhanced security. Isolating new networks are created by using VCNs, not identity domain, which focus on access and user management. So option A not a correct choice. Moving on to option number B, establishing a secure private connection between the tenancy and other Oracle Cloud services. Secure connection between services are handled by networking configuration, not by identity domain. So again the wrong choice. Moving on to option number C, rules sorry define the role and privileges assigned to a user for a group of users within the tenancy. Rules and privileges are managed within the identity domain, but its scope including broader identity and access function beyond just role assignment. So again the wrong choice. So let's look into option D. Provide a centralized location for storing and managing user credential and access. And identity domain centralized using access and credential management across Oracle Cloud services. So option D will be the correct choice. Okay, let's look into question number 7. Which statement is true regarding automatic backup in Oracle database at the rate Azure? Okay, let's look into the options. Option A, backup are stored in non-Oracle managed cloud services and require manual intervention restoration. Backups are managed by Oracle and stored in OCI with automated restore capabilities. So option not the correct choice. Moving on to option number B. Oracle Data Guard configuration do not support automated backup configuration. Data Guard configuration support automated backup and recovery. So again the wrong choice. Moving on to option number C. Full backups can be scheduled weekly and incremental backups can be scheduled daily, with both backup types stored in OCI object storage. Full and credential backups are secure and stored in OCI object storage to support automated recovery in Oracle database at Azure. So option C might be a potential answer. Let's keep it. Moving on to option number D. Automated backup are only supported for on-premises Oracle data Exadata deployment and not for Oracle database at Azure. Automated backups are supported in Oracle database at Azure and are not limited on on-premises Exadata deployments. So option D also incorrect. So option C will be the correct choice. Okay, let's look into question number 8. An enterprise has a workload running in a VNet in Microsoft Azure and a database running in a VCN in Oracle Cloud Infrastructure. The enterprise wants to set up a private, secure, and isolated location network connection between the two clouds to enable traffic flow between the workload and the database. Which two options can be used to achieve this requirement? Okay, let's look into the option. Option A, use Azure Express Route and Oracle Fast Connect to create a private interconnection between the Azure VNet, and OCI VCN. Azure Express Route and OCI Fast Connect together enables a dedicated private interconnect between Azure VNet and OCI VNS. So option A might be a potential answer. Let's keep it. Moving on to option number B. User Azure VPN and Oracle FastNet Connect to establish a private and secure tunnel between the Azure VNet and OCI VCN. VPN is not compatible with Fast Connect or direct intercloud routing. So option B not a correct choice. Moving on to option number C. Use public internet to establish connectivity between the Microsoft Azure VNet and OCI VCN. Public internet does not meet the requirement for private and isolated connectivity. So again the wrong choice. Moving on to option number D. Use Azure private link to create a private connection between the workload and the database. Private links is for Azure internal services, not cross cloud connection. So option D also incorrect. So option A will be the correct choice. Okay, let's look into question number 9. An organization has decided to implement a multi-cloud solution by using Microsoft Azure for their front-end data analytics application and Oracle Cloud Infrastructure for their backend Oracle Autonomous Data Workhouse. In this scenario, how can an organization ensure low latency data transfer between the front-end application and the backend data warehouse? Okay, let's look into the options. Option A, leverage a VPN gateway to create an encrypted tunnel between Azure and OCI for secure data transfer. VPNs offer encryption but lack in performance and reliability of dedicated interconnects. So option is not a correct choice. Moving on to option number B. Implement a hybrid cloud approach by integrating on-premises infrastructure with both Azure and OCL. Integrating on-premises infrastructure does not address direct cloud-to-cloud connectivity between Azure and OCI. So option B not the correct choice. Moving on to option number C. Establish and dedicated private connection between Azure and OCI using Azure Express Route and Oracle Fast Connect. A dedicated interconnect using Express Route and Fast Connect ensures secure and high-speed data transfer between Azure and OCI. So option C might be a potential answer. Moving on to option number D. Use public internet connection to data transfer between Azure and OCI. Encryption the data in the transit. Public internet introduce latency and security risk despite encryption. So option D also incorrect. So option C will be the correct choice. Okay, let's look into question number 10. Which statement accurately describes Oracle database at the Google Cloud? Okay, let's look into the option. Option A. It is a service that migrates all Oracle database to the Google Cloud platform. Migration is not automatic. It's customer driven process. So wrong choice. Moving on to option number B. It requires complex cross-cloud connection network configuration for access. Networking in pre-integrated and simplified between Oracle and Google Cloud. So option B not a correct choice. So moving on to option number C. It is a joint venture where Oracle and Google co-manage all data operations. Oracle manages the database operation while Google Cloud provides infrastructure and network supports, forming an collaborative service model. So option C will be the correct choice. Okay, let's look into question number 11. What is the primary function of the connectivity link between the OCI child site and OCI parent site in the context of Oracle database at the Google Cloud? Okay, let's look into the options. Option A, to provide high throughput connection for Google Cloud services to access OCI resources. The connectivity link is not intended for enabling Google Cloud services to access OCI resource directly. So option A not a correct choice. Moving on to option number B. For control plane operations such as infrastructure management and data plane operations such as backup and disaster recovery. The connectivity links support control plane tasks like infrastructure management and data plane functions such as backup and disaster recovery. So option B might be a potential answer. Let's keep it. Moving on to option number C. To facilitate data transfer between Google Cloud application and Oracle databases. App to database traffic flows locally within Google Cloud, not via this link. So option C not the correct choice. Moving on to option number D. To enable seamless integration between Oracle and Google Cloud Support Team. Support Team integration is not a purpose of the connectivity link between OCI child and parent sites. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 12. How is Oracle database at Google Cloud connected to the broader Oracle Cloud infrastructure? Okay, let's look into the options. Option A, through a public internet connection with robust security measure. Public internet is not used in the link is private and fiber based. So option not a correct choice. Moving on to option number B, using Google Cloud internal network infrastructure for seamless connection. The connection is managed by Oracle, not Google Cloud internal network. So again the wrong choice. Moving on to option number C, by leveraging a shared virtual private network connection. VPNs lack in performance and reliability of dedicated fiber links. So again the wrong choice. Moving on to option number D, via dedicated and redundant dark fiber network managed by Oracle. Oracle uses a dedicated redundant dark fiber network to secure connection of Google Cloud database to the broader OCI infrastructure. So option D will be the correct one. Okay, let's look into question number 13. A company wants to seamlessly build a private interconnection between their OCI and Microsoft Azure environment with consistent performance and low latency. They want to enable their cloud engineer to set up a single sign between Microsoft Azure and OCI for their Oracle applications such as PeopleSoft, JD Edwards Enterprise One, and e-business site. Which technology integration can be the company use to achieve this goal? Okay, let's look into the options. Option A, cloud internet and virtual WAN. These are generally Azure networking tool not designed for OCI Azure multi-cloud integration. So again the wrong choice. Moving on to option number B, Oracle Fast Connect and Azure Express Route. Oracle Fast Connect and Azure Express Route enable a secure high performance private interconnect and support SSO integration for Oracle application across cloud. So option B might be a potential answer. Let's keep it. Moving on to option number C, OCI site-to-site VPN and Azure site-to-site VPN. VPNs and are internet-based and introduce latency and reliability concern, unsuitable for mission-critical Oracle apps. So again the wrong choice. Moving on to option number D, Direct Connect and Azure NPV Gateway. Direct Connect in AWS specific NPV gateways is not relevant to OCI Azure integration. So option D also not a correct choice. So option B will be the correct one. Okay, let's look into question number 14. A consulting company that employs Oracle Cloud Infrastructure architects has successfully completed resource migration from Microsoft Azure to OCI and no longer requires the Oracle Fast Connect circuits to Azure. The project manager has asked you to delete all resources involved in the cross cloud connectivity. From the Azure side, you deleted resource group. After a while, you notice all the Azure resources have been deleted except the Azure Express Route Circuit Connect. What could be the potential reason for this issue? Okay, let's look into the options. Option A, your bill from the OCI side needs to be paid in full before you can remove the Azure Express Route circuit. Billing status does not affect Express Route circuit deletion in Azure. So So option A, not a correct choice. Moving on to option number B. You need to first delete the Oracle Fast Connect circuit for the Express route circuit to be decommissioned, and then you can delete the Express route virtual circuit. The other Express route circuit can't be deleted until the linked Oracle Fast Connect circuit is first disapproved. So option B might be a potential answer. Moving on to option number C. You need to remove the other Express route partner service key from the Oracle Fast Connect circuit, and then you can delete the Express route virtual circuit. The key is a part of provisioning, but deletion depends on the circuit state, not key removal. So option C not a correct choice. Moving on to option number D. You need to remove all routes that point to the cross cloud connection on both OCI and Azure before you can delete the circuit. Routes should be cleaned up, but they don't block circuit deletion if fast connect is still active. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 15. What components are required for setting up Azure VNet to Oracle Cloud Infrastructure VCN connection as part of an OCI Azure interconnect? Okay, let's look into option. Option A, an Azure VNet with subnet and a virtual network gateway, and an OCI VCN with subnet and an attached dynamic routing gateway. DRG is required for fast connect and cross cloud routing with Azure. So option A might be a potential answer. Let's keep it. Moving on to option number B, an Azure VNet with the subnet and the virtual network gateway, and an OCI VCN with subnet and an gateway attached service gateway. Okay, moving on to option B. Service gateway is used for OCI services like object storage, not external cloud interconnects. So option B not a correct choice. Moving on to option number C. An Azure VNet with subnet and a virtual network gateway, and an OCI VCN with subnet and an attached NAT gateway. NAT gateway supports during outbound internet traffic, not private internet connection. So again the wrong choice. Moving on to option number D. An Azure VNet with subnets and an virtual network gateway, and an OCI VCN with subnet and an attached internet gateway. Internet gateway enables public internet access, not private cloud-to-cloud routing. So again the wrong choice. So option A will be the correct one. Okay, let's look into question number 16. Which type of traffic is not supported by the OCI Azure Interconnect? Okay, let's look into the options. Option A, traffic between an Azure VNet and an OCI VCN. The OCI Azure Interconnect supports direct traffic between an Azure VNet and an OCI VCN using private, low latency connectivity. So option A not a good answer. Moving on to option number B. Traffic between an Azure VNet and peered OCI VCNs in different region. Paired OCI VCN in different region can exchange traffic with Azure VNets through the Azure Interconnect using proper routing configuration. So option B might be a potential answer. Let's keep it. Moving on to option number C. Traffic between an Azure VNet and peered OCI VCN in the same region. Peered OCI VCN in the same region can exchange traffic with Azure VNets through the OCI Azure Interconnects. So option C not a good answer. Moving on to option number D. Traffic between an on-premises network and Azure VNet through the OCI VCN. Transit traffic from on-premises to OCI via OCI VCN is not supported by OCI Azure Interconnect. So option D again the wrong choice. So option B will be. Okay, let's look into question number 17. What is the purpose of using Oracle Cloud Infrastructure Identity and Access Management policies in a cross-cloud connection between Microsoft Azure and OCI? Okay, let's look into the options. Option E, to control the bandwidth of the connection between the Azure VNet and an OCI VCN. IAM policies do not govern bandwidth that handled by network configuration. So option is not the correct choice. Moving on to option number B, to control who can manage OCI, route tablets, network security groups, and security lists. OCI policies define who can manage network components like route tablets and security lists and NSGs in cross cloud setup. So option B might be a potential answer. Let's keep it. Moving on to option number C. To control the location of the cross cloud connection. IAM policies don't determine physical or regional placement of connections. So option C again the wrong choice. Moving on to option number D. To control the type of traffic allowed between the Azure VNet and an OCI VCN. Traffic rules are set via NSGs and security lists, not IAM policies. So option D again the wrong choice. So option B will be the correct one. Okay, let's look into question number 18. An e-commerce company experienced periodic surges in traffic during seasonal sales events. Their core application is hosted on OCI while their AI-powered recommendation engine runs on Google Cloud. To handle this traffic surges efficiently, the company requires A. Quickly to scale bandwidth between OCI and Google Cloud and minimal disruption to existing configuration when making adjustment. What is the most appropriate configuration to address the company's requirement during traffic surges? Okay, let's look into the options. Option A, provision a new interconnect entirely from scratch for each traffic surges to ensure redundancy and scalability. Reprovisioning is slow, disruptive, and inefficient for surge handling. So option A not a correct choice. Moving on to option number B. Use Oracle Interconnect for Google Cloud to provision an additional virtual circuit and configure it for equal cost multipath routing. Provision an extra virtual circuit with ECMP enables scalable and low disruption bandwidth between OCI and Google Cloud during the traffic surges. So option B might be a potential answer. Let's keep it. Moving on to option number C. Upgrade the existing bandwidth during traffic surges and downgrade it once the surges end. Bandwidth changes require downtime and reconfiguration. So option C not a correct choice. Moving on to option number D. Configuration a new VPN tunnel between OCI and Google Cloud to add extra bandwidth during high traffic periods. VPN lag performance and reliability for high throughput search traffics. So option D also not a correct choice. So option B will be the correct one. Okay, let's look into question number 19. Which statement accurately reflects the cost structure associated with Oracle Interconnect for Google Cloud? Okay, let's look into the option. Option A. Google Cloud charges data egress fees for all interconnect related data transfer between OCI and Google Cloud. Google Cloud does not charge egress fees for traffic over the Oracle Interconnect. So option A not a correct choice. Moving on to option number B. Customer pay outbound data transfer fees to Oracle data for data sent across the interconnects. Oracle does not charge outbound data transfer fees for this interconnect. So option B not a correct choice. Moving on to option number C. Customers are only charged for port hour fees for each cloud provider with no cross cloud data transfer fees. Customers are only billed port hour fees for each provider with no cross cloud data transfer charges for OCI and Google Cloud Interconnect. So option C might be a potential answer. Let's keep it. Moving on to option number D. Both Oracle and Google Cloud charges separately provisioning fees for virtual circuits in addition to port hour fees. Oracle Interconnect for Google Cloud does not involve separate provisioning fees for virtual circuits, only port hour charges are applied. So option D also not a correct choice. So option Z will be the correct one. Okay, let's look into question number 20. What is involved in the maintenance of Exadata infrastructure in Oracle database at Azure? Okay, let's look into the option. Maintenance of Exadata infrastructure in Azure involve application of infrastructure and storage updates in rolling fashion with customer preference of maintenance schedule. Exadata infrastructure maintenance is Azure applied infrastructure and storage updates in a rolling fashion with customer control scheduling. So option A might be a potential answer. Moving on to option number B. Maintenance of existing infrastructure in Azure involves application of infrastructure and storage updates in non-rolling fashion on days fixed by Oracle. Oracle does not enforce fixed days and non-rolling updates for Exadata Azure. So option B not a correct choice. Moving on to option number C. Maintenance of Exadata infrastructure in Azure involves application of storage updates in on-rolling fashions on days fixed by oracles. Updates cover both infrastructure and storage and are rolling and not rolling. So option C not a correct choice. So option A will be the correct one. Okay, let's look into question number 21. Provisioning of Exadata database service in Oracle database at Azure required delegated subnets. When is the subnet delegation step actioned? Okay, let's look into the options. Option A. Subnet delegation action takes place when you provide subnet detail during the provision of Exadata VM cluster in Oracle database at Azure. The subnet must already be delegated before VM cluster provisioning begins. It is not configured at the stage. So option A not a correct choice. Moving on to option number B. Subnet delegation is a requested step that must be completed before you can provision Exadata cluster in Oracle Database Azure. Subnet delegation must be complete beforehand as a requested to provision the Exadata VM cluster in Oracle Database Azure. So option B might be a potential answer. Let's keep it. Moving on to option number C. Subnet delegation action take place when you are provide subnet detail during the provision of Exadata infrastructure in Oracle Database Azure. Delegation is tied to VM cluster setup, not infrastructure provisioning. So option C not a correct choice. Moving on to option number D. Subnet delegation step is completed during the onboarding of Oracle Database Azure. Onboarding does not complete subnet delegation automatically. So option D not a correct choice. So option B will be the correct one. Okay, let's look into question number 22. What is the correct sequence for provisioning resources in an Oracle database added Azure services? Okay, let's look into the options. Option A. Provisioning the container and pluggable database, the Exadata infrastructure, and then the Exadata VM cluster. Database require VM cluster and infrastructure to exist first. So option A not a correct choice. Moving on to option number B. Provisioning the Exadata VM cluster, the container and pluggable database, and then the Exadata infrastructure. VM cluster depends on pre-provisionized infrastructure. So option B not a correct choice. Moving on to option number C. Provision the Exadata VM cluster and then Exadata infrastructure. Infrastructure must be set up first to support dependent resources. So option C not a correct choice. Moving on to option number D. Provision the Exadata infrastructure, the Exadata VM cluster, and then the container and pluggable databases. Provision follows the correct sequence: Exadata infrastructure, then VM cluster, then container, then pluggable database. So option D will be the correct choice. Okay, let's look into question number 23. Which statement is correct about the operational responsibility in Oracle Database at Azure? Okay, let's look into options. Customer maintain the Exadata infrastructure and software update in Azure data center. Infrastructure and patchings are managed by Oracle, not the customers. So option is the correct choice. Moving on to option number B. Azure maintain the Exadata infrastructure and software updates. Oracle, not Azure, manage the Exadata infrastructure and software updates. So option B not a correct choice. Moving on to option number C. Customer manage and maintaining the Oracle database using OCI Cloud Automation. The responsibility of the database recycles task resets with the customers while Oracle handle infrastructure and patching. So option C might be a potential answer. Moving on to option number D. Customer manages and maintain the Oracle Exadata VM cluster and Oracle databases updates in OCI. VM cluster updates are handled by Oracle. Customer manage only the database layers. So option D not a correct choice. So option C will be the correct one. Okay, let's look into question number 24. What is a unique aspect of provisioner Oracle Exadata VM cluster in Oracle Database Azure. Okay, let's look into the options. Option A, Azure subnet in VNets must be delegated for clients before provisioning. Azure subnets in the VNets must be delegated to Oracle services before provisioning Exadata VM cluster in Oracle Database Azure. So option A might be a potential answer. Moving on to option number B. Database provision occurs entirely in Azure. Database provisioning occurs within Azure, but this is not a unique aspect highlighted in the context of VM cluster setup. So option B, not a correct choice. Moving on to option number C. The process does not require any prerequisites. Provisioning Oracle Exadata VM clusters in Oracle requires prerequisite like subnet delegation, making the claim of non-prerequisite unconnected. So option C, not a correct choice. Moving on to option number D. OCPUs and storage fields are manually configured during provision. Manual configuration of OCPUs and storage is supported during provisioning, but it is not a unique aspect of Oracle database and Azure. So option D, not a correct choice. So option A will be the correct one. Okay, let's look into question number 25. Which operations are performed in Azure portal to manage Oracle database Azure resources? Okay, let's look into the options. Monitoring database metrics and logs using OCI services. OCI services are used for some tasks, but monitoring is not done via Azure portal. So option A, not a correct choice. Moving on to option number B. Scaling up database resource and configuration database backup. Scaling database resources and configuration backups are supported operation within an Azure portal by managing Oracle database at Azure. So option B might be a potential answer. Let's keep it. Moving on to option number C. Scaling up the Exadata infrastructure and running software updates. Infrastructure updates are managed by Azure, not customer via the portal. So option C, not a correct choice. Moving on to option number D. Managing database encryption keys and disaster recovery configuration. Key management is not a primary Azure portal function for Oracle DB. So option D, not a correct choice. So option B will be the correct one. Okay, let's look into question number 26. How are the resource provisioned in Oracle database and other Azure services? Okay, let's look into option number E. Oracle Exadata infrastructure, Oracle Exadata VM cluster, Oracle container, and pluggable database are provisioned in the Oracle Azure portal. Okay, let's look into option number E. Database are provisioned in Azure, but the option overstates by including container and PDBs prematurely. So option A might be a potential answer. Let's keep it. Moving on to option number B. Oracle Exadata infrastructure and Oracle Exadata VM cluster are provisioned in the OCI console and Oracle container and pluggable database in an Azure portal. All provisioning Azure occurs in Azure, not split between OCI and Azure. So option B, not a correct choice.